Okay, so we are trying to find different values. We're still going to be using our Pythagorean identities, which are the first ones on the formula sheet that I gave you. Also, we'll be using those reciprocal identities as well, okay? But in this first problem, notice that we're given cosine theta. We're told that it's in the first quadrant, right? It's between 0 and 90 degrees. And they want us to find sine theta, okay? So some time ago, we could have drawn a picture to figure this out, but now we want to focus on using our identities to help us with this. So we're going to do cosine squared theta plus sine squared theta equals 1, right? That is one of our Pythagorean identities. It's on your formula sheet, okay? And we're going to use that, since that connects cosine and sine, we'll use that to help us figure out what sine is. So for cosine theta, I'm going to plug in 5/13. We can square that. Okay? And then when I square it, I get 25 over 169. And then now I'm going to subtract that 25 over 169 from both sides. While I'm doing that, I'm going to rewrite 1 as 169 over 169. Okay? So we get sine squared theta is equal to 144 over 169. Or if we take the square root of both sides, we get that sine theta is equal to 12 over 13. Okay? Now, yeah, we know that this one, they told us that theta was in the first quadrant. So we know in the first quadrant, sine and cosine are positive. So that's why I don't need to worry about the negative answer. Okay, technically it would be plus minus, but we'll pay attention to the quadrant that the angle is in, and that'll determine for us if it's positive or negative. Okay? Questions about that? Okay, let's try another one. Okay, we got tangent theta is equal to 5/12, and again, theta is between 0 and 90 degrees. They want us to figure out what secant is. Which equation ties together tangent and secant? Yes?
1 plus tangent squared theta equals secant squared theta.
Very good. Okay, 1 plus tangent squared theta equals secant squared theta. That's one of our Pythagorean identities. Okay? So I can use that to help me figure out what, in this case, secant is. So tangent is 5/12. We're going to square that and add it to 1. That's going to give me secant squared theta. Okay? So 5/12 is squared is 25 over 144. And of course, I'm going to think about 1 as 144 over 144. I want a common denominator. And so we get 1, or what do we get? 169 over 144. Or secant theta is equal to 13 over 12. Again, I'm just going to use the positive answer because we're still in quadrant 1. Questions about that? You need to run get some more? That's okay. Very good. Yes,
So are most of the answers we're going to be using going to be
perfect squares.
Yeah.
No, I mean, I think a lot of them will be, but there will be a point where we'll do some rationalizing as well. Okay. So yeah, they started us out kind of spoiling us, giving us nice squared numbers. Okay, and here we are, right? It's over. Okay, if secant theta is equal to the square root of 209 over 11, what is cosine theta? Well, this one's not so bad. What's the relationship between secant and cosine? They're reciprocals of one another, right? So if I want to figure out what cosine theta is, it's going to be 1 over secant theta. Okay, so we're doing 1 over square root of 209 over 11. Okay. And so we handled that by doing 1 times 11 over square root of 209. Okay. And if I want to rationalize that, then we can do multiply by square root of 209 top and bottom. And when I do that, I get 11 root 209 all over 209. Okay, so we were able to find cosine in that way. Questions about that?
So when you start with that, you find what cosine, you get 1 over secant theta. So then from there you multiply the top of the secant theta with 1 to the 209 square root over 11, and then you get that following step. Is that where that's?
You're talking about this step right here?
Yes.
So I just plugged in what they gave me for secant, right? So 1 over, right? What they gave me for secant. Well, because I'm dividing by a fraction, the way that we handle that is we multiply by the reciprocal of the thing that we're dividing by. So I had 1 divided by this fraction. Now it's 1 times the reciprocal of the fraction. So 11 over the square root of 209. And then I rationalized with this piece. Okay, all right, very good. Okay, we got tangent theta equals -3/4. And notice we're no longer in quadrant 1. In this one, which quadrant are we in? Quadrant 4, that's right, quadrant 4. Okay, because we're going from 270 to 360. So we already know some things about tangent in quadrant 4 is negative, but secant in quadrant 4 is going to be what? Positive. So we'll need to pay attention to the quadrant that we're in and the sign that, the function that we're looking for has in that quadrant. All right, but otherwise we can still use 1 plus tangent squared theta equals secant squared theta. Okay, so we get 1 plus -3/4 squared. And we're trying to figure out what secant theta is. So -3/4 squared is going to give us 9/16. Okay, and we can rewrite 1 as 16 over 16 plus 9 over 16. That gives me 25 over 16. So we get secant squared theta is equal to 25 over 16. Secant squared theta equals 25 over 16. This is the one that we're working on. All right, and so if I take the square root of both sides, we get secant theta is equal to what? 5 over 4. And, you know, again, technically it could be plus or minus, except we already know that we're in quadrant 4. And in quadrant 4, secant and cosine are positive. Okay, questions about that? All right, super. Okay, again, this one should be pretty straightforward. What do we need to do?
Since cotangent is not, it's not in the same equation, you need to take 1 over tan.
Okay, we can just flip it, right? Tangent and cotangent are reciprocals. And we can just go ahead and flip it. We don't have to go through all the steps. If tangent theta is equal to negative root 6 over 4, cotangent theta is going to be negative 4 over root 6. We just flip it. Okay? And then we're going to rationalize by multiplying top and bottom by square root 6. So that gives me negative 4 square root 6 over 6. And of course, we can reduce this. We can factor out a 2 from the top and the bottom. And that's going to leave me with a 2 here and a 3 here. So my final answer is going to be negative 2 root 6 over 3. Questions about that? Very good. All right. Okay, so this starts the second set, and you saw at the top of the page the assignments that you're going to be doing. So this one starts the second set. It takes us, we have to go through an extra little step, right? So if you look at this first one, we've got secant theta, and they want us to find cotangent theta. But we don't have a formula or an equation that ties those two together directly. So what do you think we might be able to do? That would be just one extra step.
You
Pardon me.
find the tangent and secant one, and then you find the secant.
Yes, very good, okay? So, you know, we know that secant is related to tangent, right? We know that 1 plus tangent squared theta is equal to secant squared theta. And if I can figure out what tangent is, then I can figure out what cotangent is, right? Just by taking the reciprocal. So we're just adding one extra little step here, okay? So I'm going to plug in for secant 17 over 8. Okay, and so we get tangent squared theta equals 17 squared, I believe, is 289. Somebody check that for me.
Yeah.
Okay, and so I'm going to subtract from that 1, or 64 over 64. And that's going to give me what? 225 over 64. Okay, and I can take the square root of both sides. Square root of 225 is 15. And square root of 64 is 8. So now I have tangent. Okay, but what we were trying to find was cotangent. And so we know cotangent is just the reciprocal. If tangent theta is equal to 15 over 8, then cotangent theta is equal to 8 over 15. And I'm going to check to make sure, that matches up with the quadrant I'm in. I'm still in quadrant 1, so this is my final answer. It'd be 8 over 15, positive. All right. Okay, let's maybe do one more. Then you'll have some time to work on this on your own. Let's do, I guess we'll do this one. Yeah. All right, so we got secant theta again. They want us to figure out what cotangent theta is. So we're going to use that same connection that we just looked at. 1 plus tangent squared theta equals secant squared theta. Okay. And so we got 1 plus tangent squared is equal to negative 3 root 2 over 4. Okay. When we square that, we get what?
Negative 18 over 16.
Okay, 18 over 16. It's going to be positive. Negative times negative gives us the positive. Okay, 3 squared is 9. Square root 2 squared is 2. 9 times 2 gave us the 18. Okay, and I'm going to go ahead and subtract 1 from that. That gives me tangent squared theta. Okay, and so I can think of 1 as 16 over 16. So we're going to be left with 2 over 16 for tangent squared theta. Alright, and if we're thinking about cotangent, that's what we really want. I can say cotangent squared theta is equal to 16 over 2, or 8. Alright, we just flipped it. And I just want to know what cotangent is. Is it what?
Oh,
Not 4. What's the square root of 8? 2. There's a little more than that.
2.25.
He said 2.5. No. 2 square root 2.
oh,
Right? 2 square root 2. Okay? How do we do that? Square root of 8. I'm going to think about a factor that's a perfect square. That would be 4 times 2. The square root of 4 is 2. But that other 2, he's got to stay beneath the radical. So, 2 root 2.
no.
Okay. Yes, y'all forgot.
You remember.
Okay? So, see what you can do with those two activities in IXL. Okay, they're listed at the top of your sheet. So yes, that's what we'll be doing today, and they'll be due next time. Okay?